Hi there students, this is Dr. John, your physics and math professor. Today we're going to start a set of videos dealing with optics. Specifically, we're going to look at what happens to light when it hits a thin curved mirror or a thin lens. I'm going to explain what I mean by thin mirror or thin lens in another video. But for now, let's just look at what happens when light hits a curved mirror like we have here. Now, this is a topic that's very confusing for a lot of high school physics students. I know I found it confusing when I was in high school, so I've tried to really study this carefully and explain it really clearly to you. And I've also, on my website, which you can check out, there are a bunch of study sheets like this one over here that you can download. It's completely free. You don't have to register or anything. I want to be the go-to place for high school physics and math students where you can learn and get, hopefully, your confusion cleared up. So please subscribe to this video. That helps me to make more videos as well. So without any further ado, let's get started on this. So here we have a flat mirror. This mirror, this would be the wall. The checkered area here is the wall. Nothing really happens on this side of the wall. So here's a mirror, and this is the normal to the mirror. Normal is the perpendicular. It's 90 degrees to the wall. The word normal comes from the Latin norma, which is the carpenter's tool, the carpenter's square that ancient people would use to draw 90-degree lines on walls or on floors and stuff. So that means normal. Normal has many other uses, but here in mathematics or physics, we use that word to mean perpendicular. So it's the perpendicular to the wall. Now when light comes in, here's the green light coming in, it will reflect off the mirror. How will it reflect? Well, if you think of the angle between the normal and the incoming light, that's called the angle of incidence, which when it reflects, it will reflect at an angle of reflection, which is the angle between the normal and the light going out. Now, with a mirror, the angle of incidence is equal to the angle of reflection. Just like a ball. If you bounce a ball on the floor, it's going to bounce upward at about the same angle that you threw it in on. Now, what happens if we curve the mirror? Here I'm curving the mirror in two different ways. Down here I'm curving the mirror like this. I'm taking the outsides and curving them inward. And up here, I'm taking the outsides and curving them outward. You've seen different mirrors like this, maybe in a makeup mirror that you look at that's curved inward or outward, or at a fun house at the fair or something. You've seen mirrors that are curved in different ways, and they reflect light in different ways and create different kinds of images. We're going to taking a look at that right here. So here we have a curved mirror that's curved inward like this, and what we do is we have this thing called the center of curvature, which you think about if you put your finger and your thumb there. The mirror would form a circle around the center of curvature. And in a similar way here, this mirror, if I can do this, do it like this maybe, you put the center here, would form a center of curvature like this. So this is called the center of curvature of the mirror. Here it's sort of behind the mirror. I've also made checkered lines there. Light can't come onto this side of the wall. So we're going to take a look at what happens with light. We're going to start off with this one. Well, first of all, what do we call these? We call this a concave mirror. Why do we call it that? Well, there's various reasons why we call it that, but I'm going to give you a way to remember that name. This is called a concave mirror and a convex mirror. They're both cons. Like at a country fair, people try to con you, so that helps you to remember that part. That's not where the word comes from, but that just helps you to remember it. And this is shaped like a cave. Light is sort of going into a cave because caves have these rocks on the top and the bottom, and you're trying to get into the cave. So light can go right into the cave, hence this is concave. It's a concave mirror. This one over here, light comes down, but it gets reflected away here. So it can't get into the cave. It's vexed. The word vex means troubled or having difficulty. So this light has trouble getting into the cave. It can't, in fact, because the cave's at the wall. So this is called a convex mirror. That's not why it's called that. That might help you to remember. If it does, then use it. So what we do is we draw the mirror like this. This is the concave mirror. And then we draw an axis called the principal axis. And then we put things on the axis. So here we put an object, labeled often with the letter O, and we draw it with an arrow like that, with the head of the arrow going up so that you know what is the upside of the arrow. If we would draw it upside down, the head would go down. So think of a person here with their head there and their legs down there. And we draw rays of light that come from here. Usually you try to draw two rays of light and see if they hit somewhere, because that's an important thing. So first of all, let's take a look at this ray of light. This purple ray of light is going to come in here. And then what is it going to do? Well, think of this. Remember, this is the center of curvature of the mirror. This is the angle between the center of curvature, which also, if it hits the mirror right here, is the normal to the mirror. So this would be at 90 degrees to the mirror. Just like this normal, it's just the mirror is sort of twisted. So what would happen to this ray of light? I'm going to erase this because there's too many things going on there. Well, just think about this. The ray of light would come in here at this angle, just like it does here, and then it would reflect at the same angle, which means it's going to reflect somewhere in here where this angle is the same angle as that angle over there. I'm going to redraw this here. Give me 2 seconds. Now notice here I've drawn the reflected light. This angle of incidence is going to be equal to this angle of reflection because the green line is the normal to the surface here. It's the perpendicular to the surface. And this light is going to come and hit this principal axis somewhere inside, somewhere between C and where the mirror is. Now what would that point be? I'm going to actually calculate that for you in another video, but we call this the focal point. I'm going to just draw a little F there, the focal point, which means the light from objects here tends to hit right here. If we drew another line from here, here, and hit here, it would also hit here. If we drew a line on this side, it would also come back and hit here. So notice that all the light from different places over here, if you draw a parallel line, parallel to the principal axis, all converges at that focal point. So this is called a converging lens. Just like if you're talking together, a bunch of you, and your opinions start to get the same, your opinions are converging, or roads can converge together. Now what happens here? Like, let's say we draw another. Remember we talked about drawing a multiple rays, at least 2 rays, and this time we're going to go and hit the center of curvature. And then let's continue that ray all the way till here. Now think if here, this is the center of curvature, remember? So this here would be another normal. This would be another 90 degree, another perpendicular, which means light that would hit here would reflect straight back. So think this ray of light would come here and then reflect straight back. This ray of light would come here and hit here. Notice those 2 rays of light hit or connect right here. So that means what you're going to have here is this same object formed right there, but upside down, because the different rays of light, if we come in with different heights of rays of light, we're going to form the arrow over here. And the 2 rays of light that we drew here, the very easy ones, are going to hit right there. And we're going to have this arrow formed upside down, and this is called the image. Notice it's an upside down image. And notice also something else, and that is this image is on the side that it should be on. Mirrors should reflect light this way. Nothing should really happen on this side, which means that this is a real image. It's a real upside down image. So now we're going to go over here and see what might happen to a convex mirror. Take a look at a couple of rays of light there as well. Let's start off with this first light. Just like we did here, this ray of light is going to come straight in here. And notice I drew a line here, this green one that hits the mirror. This also is the center of curvature right here. So that means this is at 90 degrees right here. So this is at 90 degrees to the mirror. And this would be like the angle of incidence. Just like here, this is the angle of incidence, which means the light's going to reflect on the other side of this normal at some angle over here. And I'm going to draw that line here for you. I'm also going to draw what would happen if we go backwards with that line. And I'll explain why we do that in a second. So I've redrawn the arrow here. Here's the incoming light. And notice it hits the mirror here, and this is the normal. So it would reflect on this side of the normal. This would be the same angle, just like these 2 angles here are the same, and it would reflect in that direction. Now notice if light would come in from here, it would also reflect in that direction. Light came in from here, it would reflect in that direction. So notice the light seems to be going away from each other. They don't converge anymore. What do? They actually diverge. Roads diverge in the woods. That means they go further apart. That's what rays of light here do. So this is called a diverging mirror. It diverges because the rays of light spread apart. So let's take a look and see what might happen here. So this ray of light would go this way, it would come in this way, and end up going that way. Now what happens if we dot this back? So I'm sort of saying, where does this ray of light look like it's coming from? Well, it looks like it's coming from here. And in a similar way to over here, where we said that this halfway between here is the focal point, this light is actually going to hit roughly halfway between there, and we're going to call that the focal point as well. There's your F, and that's roughly halfway between the lens and there. The light seems to be coming from here and going in this direction, like this. Like that, there. Now let's draw another ray of light. How do we draw another ray of light? Well, think of the center of curvature here. Then what if we took the center of curvature right here where it would touch the lens here and extend a ray of light here? So it would come in here, hit the here, and then come right back to the lens. I'm going to draw that in for you so it's nice and neat. So I've drawn this line in here in the same green as this one. Notice here the center of curvature. If I make a center of curvature right here and then continue on right to the tip here, this green here, just like this green, would also be a normal. It would also be at 90 degrees to the lens right there, which means light from here, let me make this nice and dark, light from here would come this way and reflect straight back, because the angle of incidence would be 0 and the angle of reflection would be 0 as well. So then let's say, where does this light seem to be coming from? Well, it seems to be coming from here. Now notice here, the light that seems to be coming from the center and the light that seems to be coming from the focal point both seem to meet right there. So I'm going to draw something in with red, just like I did before. Notice that these two lines come from the head of the arrow, which means we would form the head of the arrow here. So this is like a image as well. It's not quite like the image in this case, because the image over here is formed where there is a wall. There should be no image there. There should be no light going here, which means this is a virtual image. It's not a real image. This is a real image because it's where light should be reflecting, but light should not be reflecting on this side. So this is called a virtual image. And it's also an image, but it's called a virtual image. So virtual image where light should not be, real image where light should be. So if that helps, like and subscribe and check out my next video. I'll see you soon. Bye-bye.